success is booking very small meetings because they will fill up their meeting. And once was at Kütt where for some reason Martin Fowler was placed to speak in a tiny room that could only contain about 20 people. That was funny. People were like standing on top of each other because he's kind of popular. But welcome to our session. We need to start because there's a lot of content in here. My name is Kütt, and I'm the information system architect at the Estonian Information System Agency. But today, in this speech, well, the previous speech when I spoke about the Estonian data embassy and so forth, was related to my job and my role, then this speech is related to my passion. Stuff that I'm really interested in. Some cool stuff that I've been playing around with on my free time for a couple of years now. I've been building software for a living for the past 20 plus years. And Agile has been a part of large chunks of that. We brought in the first Agile coach in, might have been, certainly in Estonia, might have been Baltics and probably in the Nordics in 2000. It was people who taught us extreme programming. And since then, Agile has been something that really interests me. I make absolutely no claims whatsoever about knowing anything about Agile because I haven't practiced. I can't sort of say that I've actually done Agile myself. I've worked with people who actually do, but that only illustrates the extent of my ignorance. However, there are some things with Agile that I can still talk about, and one of them is why it actually works. I stumbled upon this rather accidentally when answering slightly different questions at a school that I went to. But let's get through this speech, and you will get some answers. So, but for starters, take a seat. For starters, I want you to play a game. Everybody close their eyes. Everybody close their eyes. Come on. Close their eyes. And now imagine that a baby elephant runs in the door, comes to me, hugs me with its trunk, and runs out again. Now you can open your eyes. You know, now the questions. The imagination part is now over. Now the questions. Hands up if you thought that it was funny. That just happened. Not everybody raised their hands. Hands up if you think that that elephant will moments later be followed by some zookeepers or animal handler. Nope. Hands up if you think that I would be still continuing my speech as if nothing happened. Right. So, you see, you guys were able and fully capable of actually making decisions about something and predicting outcomes of events that have not even happened yet. I hope the door doesn't open right now, but the point is that we all have a mental model in our heads about how the world works that allows us to make that sort of prediction. Right? We don't know. We have never, has an elephant walked in the door, but all of us have a knowledge about how the world works to actually sort of make predictions about what will happen next. And that's how our mind works. That's what makes us human. We perceive the world via mental models. However, these models are inaccurate. Right? The model that predicts that I will continue and the model that predicts that I will not continue, they cannot be accurate at the same time, while both very clearly were present in the room. So, why? There are a couple of reasons. Firstly, because humans are not perfect. And I have met people that actually would object, but well, humans are not perfect. We don't know everything. We don't make perfect decisions. We don't have the capability. And humans are not perfect because evolution does not need us to be perfect. You know, when you look at you're standing on a bridge in a lake, and you make a decision about whether you jump in or not. Your mental model tells you that's a really dangerous thing to do because you might break your neck. To make that prediction, you don't really need to know how much would it hurt or how deep the water exactly is. The mental model is, you know, gives you enough information to say that that's a really bad idea to actually jump in the water like that. And that's for the 99% of the cases, that's going to be enough. Secondly, accuracy of the mental model does not really guarantee social success, which means you will, well, from the evolutionary perspective, you will not have offspring if you're not socially successful, or are less likely to have offspring. Galileo had or Giordano Bruno actually was actually burned for this thing. He had a very accurate model of the universe, very well predictable, very good predictable properties, that made him very, very unpopular. Anybody having any experience in the corporate world can relate, I'm sure. Right, and therefore, people who have an incorrect but much more popular mental model, they will prevail. That mental model will, as a mean, will dominate. And finally, sometimes math gets too complex. Simply, we don't, like if you roll the dice, the chaotic process that actually is involved is way too complex, and you know, I think it can be shown mathematically that it cannot be predicted. Non-linear and chaotic processes, if you think about the three-body problem, you might have all the information there is about these three bodies, but you will simply not be able, even if you have the brain of a demigod, be able to actually predict what is going to happen next. So we have mental models, and those mental models, for a variety of reasons, are incorrect. But from that, that's theory. But to paraphrase an old Russian saying, theory does not go blue. So, this, ladies and gentlemen, is a 3-liter bag in a box of sacrifice Shiraz red wine. Drink responsibly. Motorhead brandy. Everybody's familiar with those things, right? It's wine. It's wine in a box. There's a faucet that goes, sort of tap that goes on the side. You open it up. Everybody, come on. Everybody knows those, right? What happens if you put in the tap and open it? Wine starts flowing. And at first it goes, and then it starts going slower and slower and slower until the bag sadly is empty and somebody has to get a new one. Right? Everybody knows that this is how those bag-in-box things work. More formally, it can be depicted like this. We have S, we have outflow. Outflow depends, as we saw, everybody has experience, depends on the amount of liquid in that box. And for the sake of simplicity, let's say the way is dependent is just a multiplication by constant G. Another question is, can we find the T empty based on S0 and G? We know how much liquid there is in the beginning. Can we predict when this vessel will be empty?
It will never be empty.
You, be quiet. Anybody else? Damn it! I did not count on that. Because usually what happens is that half of the people go, yeah, of course. Everybody has emptied the bath in their lives, right? I actually thought of using the bath as an example, but since by my experience, the box of Shiraz actually works better with people with no kids I thought to go with that wine thing. But everybody has pulled the plug on a bath and seen it physically empty. And that's what happens, right? However, if you really sort of throw this out, if you solve that differential equation, it indeed solves into an exponent. The less water there is, the slower it flows. The slower it flows, you see how it goes into feedback. And the exponent will never reach zero. Yes, you have emptied the bath, but water does not flow out. What happens is that it flows until there's too little water to flow, at which point surface tension goes, droplets form and those evaporate. Again, our mental model tells us that the bath is flowing until it's empty. The bath empties by flowing. And it's 99% accurate. But so last droplets, for those, it's actually not. Our mental model is not accurate. And, other than that gentleman here, we get the physics for this in high school, and we should be able to actually predict that outcome. But we don't, and I've used this example repeatedly, and for the vast majority of cases, people say, no problem. Yes, of course we can predict. We can do the math and we can calculate it. And of course we know. And that includes students in some very highly respected universities. So the thing is just that our mental models are not accurate enough. They simply are not. They don't, because of the reasons I brought earlier. So the natural question is, what else we might be getting wrong? What about our mental model of how software projects work? Is that accurate enough? And, let's see. What I've done is I have taken a computational model, and I built a computational model and used that to sort of simulate certain scenario. Just a couple of things that I want to say about what you're about to see that are kind of important. Firstly, shape is more important than size. In a modeling world, it doesn't really matter whether something cuts some axes at 100 or 200 and 500. It is a question of the shape, whether it's shaped like that or shaped like so, whether it goes up or goes down. The model is based on the same kind of logic of the bathtub. The math is actually there. But I don't want to go into details of why it works or how it works or what the math actually is. You can look it up in the interweb. The key word to look for is system dynamics. There are also books about that. There's one copy of that, the best book of that issue in the University of Tallinn Technical University. I have not been able to actually find it because it's on the lower cost. But it's there, if you're interested. And the model has been validated. I did not invent that model, I was given that model, but I was given that model by people who have actually used it and validated it in real world based on large corporate data about projects, how projects go. And in the end, the model is so simple that it makes so much intuitive sense. It's really hard to argue against it. I'm going to show you the model later if we have time. But let's get to it. Let's start with the really simple case. We all know that all projects work like so. We start out with 100 tasks to be completed, and then we start working. We work on the project and on the tasks, and after 100 weeks have passed, we are done. Why not?
Additional work.
What additional work?
Additional work found during the implementation.
No additional work. Just the same 100 tasks. Let's assume, let's make this assumption. There are no additional tasks occurring. But there is, of course, you're right. Certain things are being omitted from this model. And by the way, it doesn't really matter what those tasks are. Digging holes, writing code, doesn't matter. It's an abstraction. Weeks also doesn't matter. 100 weeks is a fairly reasonable project. One thing that this model doesn't account for is mistakes. And one other assumption this model doesn't account for is additional work. Mistakes, it's relatively simple to explain. When you make a mistake, you have to fix it. And by fixing that mistake, you have a chance of making the mistake again, or a different mistake. And fixing that, you have also a chance that you will be making a mistake, right? So that's mistakes for you. And I have assumed 20% of chance of making a mistake. And for the reconstruction work, that's slightly more difficult. The logic behind it is that once you have built an API, and you have a mistake in the API, you will need to change all the code accessing that API as well as the API if you discover the bug. And the further along the project you are, the more damage there is. And the model I've used is assuming making fairly reasonable assumptions about, on average, doubling the work in the end. If on the last day of the project a bug is found, it takes twice as much effort as actually redoing the work. On those fairly reasonable assumptions, how much longer will the project take? 20% rate of making mistakes, that's not too bad. So, any assumptions? How long will the project take now?
Off the chart.
It's not that bad. And I'm not that bad at preparing slides. I've taken care of that. The axis will actually be sufficient. The green lines should have made it larger. The green line. From 100 weeks, we get to 225. It's the same productivity, the same people, same rate of work, everything is the same. Two things added: 20% chance of making a mistake, and work is able to cause rework. More than doubles. 2.25 times longer project. Oops. The thing is that the naive view is really dominant. People really think that doing anything works like that. But that's not the case. All right. So for the next thing, and I'm actually walking you through my sort of thinking, because I was sort of building the model and sort of trying it out and running simulations. And my next thinking was that, okay, so all right, so mistakes and rework cause that sort of delay. So let's add another factor. Let's add churn from the team. If you have a project which is now about 4.5 years, people leave, people change, you need to retrain people. Surely this is going to affect the dynamics of the project significantly. And I made certain very simple assumptions about having to recruit, recruitment time of 6 weeks and tenure of 5 years on average or something like that. And it resulted in that red line. Turns out that my mental model about the churn was completely incorrect. And that's that's the key things about modeling complex dynamic behavior, is that your mental model is almost always wrong. You need to run the math, you need to run the model to actually find out what happens. Anybody want to tell me why that churn thing didn't affect the shape of the curve that much?
The project is long. That's very nice, I would say. The effect is small because, the project has duration is that long.
Yeah, but you would still
I
say
don't know
that there are.
how long team you had in the simulation?
I had, let's say, 200 people.
Ah, okay, that big.
People leave, they don't make mistakes.
New people actually make more mistakes.
Maybe it's because that not the old people who leave once, maybe a single one.
It's actually a very good assumption, but that's why I choose a team size large enough that I don't need to deal with pressures. But the real answer is that it turns out that in case of my numbers, the team size stabilizes very rapidly. That all the time there's one position being empty, there's somebody being trained, somebody being sort of currently phasing out thinking about leaving. And that's going to be constant, which means the team output is also going to be constant. Which means that there is actually not much effect other than pushing the chart forward slightly. And that's a key thing about our mental models. You should really, in case of complex systems, you should not really trust your mental model about how something behaves. And I think everybody agrees that software projects are fairly complex.
I'm sorry.
Yeah.
Do you take into account that people are more experienced and make less mistakes?
Yeah, that was taken into account.
And the new ones?
They take some time to actually graduate from that rookie to full guy. But now this brings us to the first action point about agile. The key thing about those charts you saw was that the project flow is not linear. The project is not linear on the large scale. However, what agile does is it works on fairly small timescales, a week or two. And if you know about math and geometry, you know that a circle can be depicted with a polygon with enough sides. And that's what agile does. If you look closely enough, the chart is going to be roughly linear. And that's why agile succeeds. It succeeds because it looks at a complex project on a time scale where the complexity really doesn't manifest itself. On a small time scale, you can make assumptions about the things being linear. You can make that naive assumption without being that much wrong. And that's one of the key things agile does. This is how it works. One more thing is that if you look at the chart, there's one great thing that I just noticed about this chart. It tells you why your team velocity is very difficult to predict and get right. It simply changes over time. The slope of the graph is actually changing because that's why your team velocity is also. That's basically the slope of the chart is your team velocity. Basically, it changes in complex and nonlinear ways, and that's why it's very hard to predict and nail down. In the beginning, yes, you will zero in on the target that it is going to shift. It's going to be really hard to get right. All right. One more assumption that we actually make here is that we test all the time. That on this chart that we start discovering rework and mistakes from the beginning, and we continue fixing them and making new mistakes. And about here, the rework effect starts to kick in, so we accumulate more work and we get done. However, in the waterfall world, that's not the case. And we end up with something like this. And actually now this is off the chart. No testing done before 30% of project duration. And then, of course, all of a sudden, we start doing testing, and then, of course, oh, bloody hell, the amount of work left to do starts growing up. Goes up for at least the same amount of time that we have already spent on the project before it starts decreasing again. The life of that project manager between weeks 100 and week about 200 is not very rosy at all, because things keep getting worse. They are working. They're working all the time. They're working very hard, but the amount of work left to do is increasing rather than decreasing. That's bad. The other bad thing about this, this shape of this chart is that when I spoke about team velocity earlier, that was non-linearity is pretty bad. But for this chart, the poor project manager up to this point has absolutely no understanding whatsoever about their team velocity. They don't know. They don't know how many mistakes are being made. They simply don't know. And they live under the impression that in the naive model, that they will be done in about five weeks, which is not the case. The fallacy rate, the ratio between stuff that you think you have done and the stuff that you have actually successfully completed, is just very ugly for this this waterfall case. And of course, that's why Agile really excels. The sooner you test, the better. In Agile, testing starts immediately. You build something, you test it, you sign it off, it's done. You take the next jump. You build it, you test it, next jump. And you never get to a point where you all of a sudden discover that your team velocity is completely different from what you thought, or stuff that you built actually needs to be rebuilt, or any of these things. This is one of the main reasons why Agile is actually very, very nice for the project manager. Right, the sooner you test, the better. By the way, this applies to not only software projects. One of the simulations, actually, the reason I did this simulation was that an architecture company approached me and said, "Look, we want to go have all the different people who work on different buildings, and they work on different plans. The architect, the structural engineer, the ventilation people, the network people, the power people. We want them to work on the same sort of centralized server, to have the same model of the building, and so to work on the same thing, as opposed to working on their own different models and doing handoffs. But the central server is bloody expensive, so could you help us find a way to justify the cost?" And the examples they brought me about exactly that sort of thing was, imagine that you have almost completed a house, a building, an office building, and your ventilation people, who are one of the last people who actually come in, they discover that on the project, on the paper, they need to run a 1 meter diameter, that size, ventilation pipe through a structural beam. Breaks through it. You can't bend that bloody thing either, because there's not enough room for that. So what do? Or that you have placed a cable ladder on chest height across the staircase, because that's how the project says it's going to go. Talk about late testing and the cost of fixing mistakes. All right, but I also ran a couple of other simulations. This is a chart where we have this main case, and we have two models, the same thing as previously, with mistakes and rework, but I have varied the error rate. This middle thing here is 20% error rate, the green one is 10, and the red one is 30.
Can you explain this error rate? What does it mean?
Error rate is the probability that I do something incorrectly when I do something. If the error rate is 20%, then when I complete the task, there's a 20% probability that goes into the file that needs to be redone later. And there's an 80% chance that it actually goes to the file where it's actually done. That's the error rate.
For 5 tasks, you get 1 extra task.
Yeah, pretty much. And the important part here is that this bit is much longer than this one. Decreasing the error rate is 1.5 times as beneficial as allowing it to increase. That graph shows us that incompetence is really bad. But Agile really breeds and needs competence. One of the key questions I've never seen anybody answer is thus. If Agile is fairly complicated to get right, and only fairly competent and experienced people and teams can do Agile correctly, then isn't it the case that the projects succeed because of those intelligent and competent and well-working people rather than Agile being used? Or is it Agile? And I don't still have the answer, but what is clear is that effects of learning will be over and bad HR underestimated. You know, if you want to go down from 20% error rate to 10, that effect is probably going to be underestimated because it was relatively small. But if you allow your HR to hire people that, of course, are not in this room, but can be basically labeled as idiots, then that effect of that is going to be much larger than you probably expect. There's a difference. And does anybody, of course, realize why that is? Because if you make more mistakes, you need to make mistakes fixing those mistakes, and that's where the difference comes from. And the difference is not trivial. It's 1.5 times. I think I have also time to show you the actual model that I've used. Of course, there's a ton of nitty-gritty around, but that's basically it. There's work to do. Flows into either work done correctly or work done incorrectly. Quite the same as I explained, that ratio. There's a process called rework discover, which is in software language, software terminology called testing. And there's additional work flowing in that is the construction work that just appears because there's real work being discovered. And that's basically that. The beauty of this is that if you try to write it out using the differential equations that I used earlier, the math gets really complicated. And there's basically no way to do that by heart or even estimate what the graphs are, what the math behind these, and what the actual numbers are. But fortunately, there are modeling tools available nowadays, actually several, that allow us to actually take those sorts of fairly comprehensible, just draw boxes and lines between them, enter some formulas, press go, and it actually simulates the entire thing for you, does the math for you, which is very nice. At this point, questions, please. Yes, that's an important slide.
So what's your recommendation?
To Agile. What else? But jokes aside, you should really not take for granted your thinking about how software projects work. Because very simple math, very simple effects, it's like really trivial effects, like making mistakes is sort of like one of the most obvious things, but it produces a completely non-obvious effects on the project behavior. And you should really not take for granted your knowledge, what you think about how project management works or how software development works. There are so many sort of mental models being involved there, and we all know that they're wrong. They differ. You can't really use them to make decisions. You should try to model or rely on sources that actually use modeling. or real world data. Just data showing something, rather than typical, oh, we all know that Scrum or XP or whatever the flavor of the month is, that works. Use data or model or both.
Can you use this model to get statistics on the health of your team, for example, or how it performs?
Sure.
Can you also figure out which part is the bad part? Is it like...
No, it's statistics, it's modeling. What you can do is, use it for is that you can take the basic model, you can calibrate it using your sort of past project data, and then you can run sort of, one of the things you can do is you can run what-if simulations. What if our developers became, let's say, 5 percentage points less likely to make a mistake? Let's say our hiring goes up and we now are able to fill our positions in 4 weeks instead of 6. What impact does that have on the overall behavior? Let's say, what about change management? Do we allow changes to come in constantly or do we gate them? Mm-hmm. What is the impact of that? You can run those sort of what-if scenarios based on that model.
And how much our government IT project uses
no other people here, so I probably have to answer. None. For the very simple reason that, how do I put this in a non-offensive way?
No one cares?
The thing is that in Estonia there's, to my knowledge, and correct me if I'm wrong, and I would love to be proven wrong, in Estonia there's exactly one company who can really actually factually claim that they do agile successfully.
And who is that?
That would be endorsement and would be probably corruption, and I would go to jail for that. So I'm not going to say who the company is, but that's just one company, which means that there's a serious lack of competence. And a government is a enterprise, and doing agile in a startup is one thing. Doing agile in an enterprise context is a completely different beast. And for that reason, I would say that I'm trying to get that sort of thinking into the government, that hey guys, you might want to think about what the actual sort of like impact of your work is, and projects are not linear and you can't use that sort of naive models. I'm trying to get that sort of thinking into people, but I can't really claim that the Estonian government really does agile in any meaningful way.
But do they collect any kind of data, or like that kind of data that they can show like as a picture that, you know,
That's another thing that we're trying to get implemented is software project measurement and metrics and assessment. But the upside of is that in Estonia there is a policy that we use outsourcing, almost exclusively. There's very little in-house development, which means that if any of the outsourced partners has awesomely high maturity rates, they should have actually more data than the government, because they do work for private companies as well. So a software development house ideally should have that statistics available. Yes.
What to do if company already implemented agile and it doesn't help because they are not agile, as you said?
Start thinking. My recommendation is exactly that's something that I'm trying to sort of thank you for the question. That's exactly the message. If you just go into I'm going to do agile, that's going to be so cool. Well, yeah, you can do agile, but as you said, it's not going to help whatsoever because you don't understand why you're doing this. You don't understand the reasons why agile works. That's what I'm trying to show you here. You don't understand the reasons why something you do actually does what it does.
Well, the reason is to develop.
Do you know the concept of, anybody familiar with the concept of cargo cult? Cargo cult. I'm going to explain it very briefly. the cargo cult it was discovered on islands in South Pacific. Or in the World War II, those islands were used as a sort of fixed aircraft carrier. Americans came in, created a runway in the jungle, landed their men, landed their troops, landed their aircraft, and used those sites as sort of fueling stations for bombing Japan. War was over, Americans moved out. In the 1960s, anthropologists happened upon those islands, and what they saw was that the local people, indigenous people, were sort of standing in the end of the runway going. And there was somebody in the sort of control tower actually mumbling into the strangely sounding words into the sort of coconut. Because they knew that when those actions were performed, iron gods came from the sky and brought chocolate and alcohol and medicine. And then those gods went away. And without really understanding what the hell they were doing, they were trying to resummon the gods by performing the same actions. The law of agile is done the same way. We go through the motions, hoping to summon those agile development gods that bring bliss and knowledge and prosperity. It's going to help exactly as little as just waving your hands in the job. It's not going to bring much. But understanding why stuff works, why you're doing things, why certain disciplines work, that is something that brings balance. Now, I think, and I'm entirely sure that we are all the time. Thank you.